Hello and welcome to this short course on MongoDB fundamentals, good old RDBMS. And in this course, I will show you everything you need to know as a software developer in order to get started with any MongoDB applications. In this course, you will learn many things right from installation of MongoDB on your machine to performing CRUD operations, writing simple to complex queries, and much more. So let's dive in. MongoDB is one of the most popular NoSQL database management systems today. NoSQL stands for not only SQL. The name MongoDB is derived from Humongous DB. As against the traditional RDBMS, it stores the data in an unnormalized way in a format called as BSON, which stands for binary JSON. In 2007, a software company called 10gen began developing MongoDB, and in 2009, the company shifted to an open source development model with the company offering some commercial support and some other services. A MongoDB database contains data in the form of one or more collections. Collections are equivalent to tables in an RDBMS. What you call a record or a row in an RDBMS, here it's called as a document. Unlike records of a table which share similar column structures, documents of a MongoDB collection may contain different structure. A document, simply put, is a bunch of one or more key value pairs. The keys can be called as properties or fields as well. Here is an example of a valid MongoDB document. As you can see, name and email are two fields, and corresponding to that there are some string values. Here is another example of two documents being part of a single collection. Note that they both have some fields in common and some different. Internally, MongoDB stores these documents in BSON format, which stands for binary JSON. As I mentioned earlier, a document is a group of field value pairs. Fields are equivalent of columns in a table. Value of a field may be string, number, boolean, arrays, or even another object. Each document of a MongoDB collection must have an underscore ID field, and if you don't provide one, MongoDB itself will assign an auto-generated value of a type called object ID. A collection in a MongoDB database has a dynamic schema such that the documents in the same collection may have different structures. In RDBMS, joins are expensive, and hence in MongoDB they are not supported. A query in MongoDB operates only on a single collection. MongoDB does not support transactions either. Each insert, update, delete individually are transactional in nature, and this is because all related data are stored in a single document. Hence, there is no need to use multiple insert, update, delete operations at all. Unlike RDBMS, data duplication is encouraged here so that all related data is in the same document, avoiding unnecessary joins and subqueries. In order to install MongoDB on your Windows machine, first download the appropriate installer. So let's go to mongodb.com, and in the home page on the top right corner, somewhere you will see here that there is a download link. Let's click that. And that gives us few options, and I would like to go with the community server. And in the community server, since we are using Windows machine here, we have a couple of options. And the one that is shown by default is the one that we want to install. Let's click the download button. The download will take few seconds. So now that the download is done, so let's open the folder. And here is the installer. So let's go and double click that and complete the wizard by choosing the most appropriate options. By default, it has been installed in C drive, program files, MongoDB server, 3.4. So this is the location. And in the bin directory, we'll see some applications or executables. The one executable that we are interested right now is the MongoD, which is a server process. There is also a client application. So one thing is you can just double click this MongoD, but it fails to start up because it looks for a folder called data/db in your C drive. I don't have this folder. Hence, when we run this, we can supply an alternate folder where MongoDB will use that as a temporary folder. So in order to test this, let's open a command prompt and then type the command MongoD with probably -- version. And it gives me an error saying that MongoD is not recognized as an internal or external command. To make this MongoD command available on all command prompts, we have to add this folder location to our path environment variable. So I'm going to copy that and then right click this PC, properties, advanced system settings, environment variables, and I can add either here or I can append to an existing path here. So let's go and add a new environment variable called path and paste that location that we copied. Once you say OK, OK, and OK, let's close all the windows, and then I open a new command prompt, type the same command MongoD -- version, and we get this version now, which means you have successfully installed the MongoDB software. The next step is to create a data folder for MongoDB. So I'm going to open C drive and create a new folder. Now the name can be anything. I'll give MongoDB-data. And then I can use this path when I run the server. To run the server, issue this command from any command prompt now, which is MongoD --db path :MongoDB-data. You can also optionally change the port numbers or the location of the server, etc. But I would like to leave it to the default. When I press enter, it starts the server. And you can see that there is a message that comes up waiting for connections on port 27017. Now that happens to be the default port number. If you got this screen, that means your MongoDB installation is successful and it has been started. Now let's minimize this and open a new command prompt. This time I want to connect to the server using a Mongo client and then check if I can issue some commands. For example, I'll type Mongo and then press enter, and you will see that it connects to a server. So it says connecting to MongoDB //127.0.0.1, which means localhost, and then the port is 27017, which is where our MongoDB is running. Through this command prompt, I can issue some MongoDB specific commands. For example, show DBs will give you the list of databases that have been created and visible. Now I can create a new DB by just typing use, for example, test_db. Now it says switch to the DB test_db. However, if I again say show DBs, it will not be listed because it doesn't contain anything. So it gets lazily created, which means only when you add some data into your database, the database comes to existence. So we can also issue a command called db to check what is the name of the DB, and it says that the current database is test_db. Another command that can be used at this time is show collections. Now, since this DB is empty, there are no collections at all. However, we can add a new collection and reissue all these commands to see a different result. So let's create a new collection by adding a new document to that. And it's very simple. Just have to type db dot an imaginary collection name. For example, I can say contacts dot insert, and then I can pass on a JSON document. So with a name value pairs. For example, I can say name Vinod, email vinod@vinod.co. Now, if I complete this, you will see that it says right result, number of records inserted is 1. And if I now issue the commands show DBs, you'll see that there is a new database called test_db. If I also say show collections, I can see my collection, which is the contacts. And now to see the data which is stored in the contacts, I have to issue a command db.contacts.find1. You can observe that there is another field inserted called _ID, which has to be there for every document of any collection. Now the value for this can be user defined also, but if you don't mention, an object of a class called object ID will be created, and we will talk about this object ID in the future lessons. So now that we have created a contacts collection, we can also add arbitrary values. For example, I can create a JavaScript variable, let's say var p1 equals to an empty object, p1.name equals to Kumar, p1.email equals to kumar@vinod.co, p1.city equals to Bangalore. And now I can add this to the existing collection, which is contacts. I can say now db.contacts.insert, and then I can say p1. And now I have a second record. Now in MongoDB terminologies, a record is termed as document. And the reason is very simple. In RDBMS, a record consists of rows and columns where every row is of similar columns. But in case of MongoDB, that's not so. Now if I say db.contacts.find.pretty, you will see that there are two documents that exist with a different schema or different structure. And if you also have observed, we created the contacts collection without having to define a schema for that. So this is one advantage of MongoDB or any NoSQL databases in general. You can also add arrays of objects. For example, if I can create var p_arr equals to an array, which is like a square bracket, and then a curly bracket, and then I'll say name is John Doe and city is Dallas. Second one, probably name is Jane Doe, city, let's say Chicago, and close the bracket. So now p_arr is an array, so I can check that out, and that's an array. And now I can insert this by using the same command again. So db.contacts.insert, and then I'll say p_arr. Now since I gave an array, it's going to say that there are two documents that got inserted, and it also gives me a different response this time that says that bulk write result, there are no errors, and number of documents inserted is 2, and some other useful information. Now I can just say here that db.contacts.find.pretty, and you will see all the 4 documents are intact. If you don't use the pretty function and then just type db.contacts.find, you will see that the output is not so pretty. Now this is true especially if your document structure is very complex and nested and all those stuff. The find function returns a cursor, and since we are not collecting that, the Mongo shell displays the first 20 documents. And since we don't have enough documents, we are not seeing that of a difference. We can also import data from external files such as CSV or TSV or JSON files. So MongoDB comes up with a bunch of tools for these things. For example, if I go to the MongoDB installation folder, there is a file called mongoimport.exe. Now the Mongo import, as the name suggests, imports a file into a MongoDB collection of a particular database. So if I have to go to a command prompt and issue a command mongo import --help, it would give me a bunch of options that I can use while importing. So it says Mongo import, few options, and one file. The data can be represented as CSV, comma separated values, or TSV, tab separated values, or JSON, JavaScript object notation formats. We can also import if the data is just a collection of MongoDB documents. We'll have a look into each one of these. I have a file called contactsdata.json, and that contains 1000 contact information with similar fields. Now, it is also possible in practice that the fields may vary, that we have already seen, but in this particular case, I have all of them of the same structure. Now, in order to import this, all I have to do is to come to the command prompt and then say Mongo import, and then I have to give few options. The number one option is what kind of data that I have. Now I have a JSON array. The second important option that I may have to specify is the DB. In our case, it's called test DB. And in the test DB database, what is the name of the collection to which you want to import? If the collection name that you have given is not available, it gets created. If it's already there, it's going to add these documents into the existing collection. If you don't mention the collection, the name of the file itself will be considered as the collection. Now, since the name of the file is contacts data and I already have a collection called contacts, it is good to give the name of the collection. So I'll say dash dash collection, and then I'll say contacts. And now the last option, which is the name of the file. The path that I'm giving here is a relative path because I'm already in the c:\users Vinod folder. Relative to that, there is a folder called desktop, and there is a contacts underscore data.json. So if everything is okay, it should import 1000 documents. And now we can go and have a look at that in our Mongo shell. So I can just give a command db.contacts.say, for example, I can say count, and then that will give me 1004 because 4 documents we added earlier, and now 1000 documents have been inserted through the import command. Now if I give here db.contacts.find, you will see that I see only 20 documents, and then it says here type it for more. Now it is a short form for iterate, so I can now type it and I should see 20 more. Alternately, you can assign the find function's return value to a variable. For example, I can say var data equals to db.contacts.find. Now data here is an iterator. If you simply press data, it is as if you wanted to see the first 20 documents. You can also loop through that, or you can also say var contacts equals to data.toArray to convert that into an array object. Now I can say contacts of 0, and that's the first contacts of 1000, and that would be the 1000 first document. And likewise, I can go and access all data. Apart from running a command from within a shell, there are different ways MongoDB commands can be executed. So for example, let me just exit from the Mongo shell, and then I'm back in the C drive users Vinod folder command prompt. So I can just say Mongo and then followed by dash dash eval, followed by a command db.contacts.find1, and then the name of the database that it has to connect to when I want to issue this command, so which is testdb in this case. And you can see that it connects to the local host and 27017, that is the default port, connects to testdb and then issues that command. Obviously, this would be a very difficult mechanism if you want to issue more than one command. If I type Mongo and say dash dash eval and use testdb semicolon, and then I say db.contacts.find1, you will see that it's going to result into an error. So what we can do is alternately, we can create a script file and then execute the script file using the Mongo command. This would be a good option, especially when you are learning. So in order to test various commands, let's create a work folder for ourselves. So let's go to our C drive, create a new folder called MongoDB-examples, and then use the same thing in Sublime Text. So now we have a folder and files. Let's also get into that directory. So let's go cd MongoDB-examples, and we can issue the commands from here now. So let's create a new file. Let's call this as ex01.js. So let's say we want to issue more than one command here. For example, I want to connect to a database called testDB and then semicolon, and then I can say db.context.find1, and then I can say here var count equals to db.context.count, and then I can even say print there are plus count contacts. So now I have a script that actually can do some work, and then I want to execute the same thing here. So I can come back to the command prompt, and then I'll say mongo and then a less than symbol like an input redirection, and then I'll say ex01.js. Now this should connect to the localhost 27017, use the testDB, and then issue the rest of the commands over there. And as you can see that the commands have been successfully executed. So in order to test various commands, let us follow this approach. Let's take an example where I have a variable p1 equals to an empty object. This time we will also assign an underscore id equals to 1, p1.name equals to Smith, p1.city equals to Dallas. If I say db.contacts.insert p1 and run the same, you will see that it gets executed successfully, and it has given a result saying that the n inserted is 1. However, if I run the same thing once more, we get an error because the underscore id is more or less like a primary key of RDBMS tables. So we cannot have the same id. Now sometimes this may be a problem because we might have retrieved the data from the database and then we would have modified and we would like to save it back. So instead of the insert, if I use a save function and run the same, you will see that there is no error. However, this time it says number of matched documents is 1, upserted is 0. We'll come to the concept of upserting, but at this time it says number of modified records is also 0. That's because we didn't make any changes. However, instead of Smith, this is Martin, and save this and run the same, you'll see that this time it says number of modified documents is 1, and that's because we have some different values. It did not insert, but is just updating the existing document itself. Calling the find function on a particular collection retrieves all the documents, and all the documents include all the properties. Now, sometimes you may want to restrict the number of documents based on certain criteria, or restrict the properties that you want to view. This is called selection and projection. The first parameter is an object representing the criteria that you want to use for selection. Now we'll come back on that in few minutes, but first we will see how to do a projection. The second parameter here is the projection. For example, if you want to retrieve only the first name, last name, and city of the people in your contact list, then you can simply say here, first name is 1, last name is 1, and then city is 1. So instead of 1, we can also use any non-zero number. So 0 represents false, non-zero represents true. In fact, you can also type the JavaScript keyword true to say that include this particular property. When I save this and then execute the same thing, if I execute Mongo and then pass on the ex03.js, you will see only certain properties are being retrieved, and especially first name, last name, city. Now by default, the underscore id is always included. Now if you don't want that, you can come back to your command and then say underscore id is false or 0. So save it and run the same command again, and you can see that we get only first name, last name, and city if it exists. If the document does not contain a specific property, that property will not be included, and if it doesn't contain any matching property, just an empty object is being written. One very important point that you have to remember is you cannot have a combination of inclusion and exclusion except for the underscore ID. Apart from the ID, if you use inclusion for the properties like 1 or non-zero or true, you may not be able to specify a false for other fields. For example, if I try this, we get an error saying that projection cannot have a mix of inclusion and exclusion. So either exclude all the fields that are mentioned here and retrieve the remaining ones, or include only these fields and do not get any other fields from the documents. Now that we have seen a projection, let's see how to use selection. Now the concept is the same thing. You have to specify an object representing conditions. For example, if I want to get all the contacts from city of Chicago, so I can do the same thing like db.contacts.find, and the first argument would be the selection and the second argument would be the projection. Let's say, for example, I don't want to include the ID. I can simply say ID is 0. However, we want to specify a condition here, and that condition would be city in Chicago, and save it, and let's go and run the same thing. Mongo ex04.js. You can see that we got some records. Now, just to make sure that we see the data properly, let's also call the pretty function, save it, and re-execute the same command. And this time you can see we got some documents where the city property equals to Chicago. Giving a key value pairs like this is equivalent of saying city equals to Chicago. So the same thing can also be represented using city, and then we specify an operator which is given in the form of another object. So $eq, and then we give Chicago. So now we are saying that city equals to Chicago. So output should remain the same thing, and we got the same thing. To work with more complex queries, we need to have more complex data. So I have a file here called sales-data.docs. The extension doesn't matter, but if you look at the file carefully, this is not a JSON array. For example, JSON fields must have double-coded text, and also an array must start with a square bracket, and every JSON object must have a comma. But this is just a collection of JSON objects, one object per line. So let's import the same into a MongoDB collection. For that, let's issue the command mongo import, and the DB is testDB. And the file that we want to use happens to be called sales-data.docs. If you don't mention the collection name, the base name of the file will be used, which is sales-data. Now, I would like to have this as a collection called sales. So I'll say here --collection sales. And when I press enter, you'll see that it has imported 286 document. Let's go and have a look into that in the Mongo shell. So we have the sales and the db.sales.find, and then we'll use a pretty format to prettify the same thing. So we can see that all the documents are lined up with an automatically generated underscore ID. Now, it is important to see that we have some numerical fields such as quarter and sales amount, etc. Now, let's work on this and execute some more complex queries. Let's say we want to query for our sales collection and get all the sales where the sales amount is more than or equals to $10,000. So the query would look something like db.sales.find, and the query is on the sales amount. So we say sales amount, and then we use another object and say $GTE, and then the amount, which is $10,000 itself. And if you want to prettify the output, let's call the pretty function as well. Save it, and then I'll say mongo ex05.js, and we get a bunch of documents that satisfy that condition. And let's say we want to have all the sales where the sales amount is between $5,000 and $6,000. Obviously, we need to give a more complex query. So let's go and create a new one, and then let's call it as ex06.js. So the query would look something like db.sales.find, and the field that we want to test is sales underscore amount. It is greater than or equals to 5,000, and then we also want to specify that it is less than or equals to 6,000. So obviously we have to give multiple conditions at this time. So the query goes something like this. So db.sales.find, and we'll say $and, which is an array of one or more conditions, and the conditions are themselves objects, where we'll say sales underscore amount greater than or equals to 5,000. This is one condition, and then a similar condition where we say sales amount is less than or equals to 6,000. So this is going to be LTE. So we save it and then run the same. Of course, we also would like to do a pretty to make sure that we get the prettified output. So let's execute the same Mongo ex06.js. So you can see that we get a bunch of documents where the sales amount is between $5,000 and $6,000. Suppose we want to find out all the sales done in the Q1 or Q3. So there are two ways to do this. One is using a OR operator, or the other one is an IN operator. Let's begin with an OR operator. So we say db.sales.find, we say $R and an array of criteria, and each criteria is given as a JSON objects themselves. Since this time it's just the quarter equals to 1 or quarter equals to 3, we can just say Q1, and then another object we say quarter is 3. This should fetch the desired results. So we'll also do a pretty print. As you can see, there are a bunch of Q3 documents, and then if I scroll up, you see Q1 documents, and you don't see anything else. So this is one way to do. So, and the second method to do the same thing is db.sales.find, and then we simply say quarter, and the operator is $in, which takes an array of values that match the quarter, which is 1 and 3 in our case. And then as usual, we'll also do a pretty print. Save it and run the code. We get the similar results. You can also combine multiple criteria one after the other to give the effect of an AND operation. For example, db.sales.find, let's say category is equals to beverages, and then I can give a comma and give another condition that can say, for example, quarter $in, and then I can say 1 and 3. So if I check what is the total number of sales by using Mongo ex08.js, you'll see that there are 22 documents that match this criteria. But if I include or if I remove this condition and then try the same thing once more, you will see that there are more number of products. There are 46 documents that match this condition. So giving multiple conditions are going to narrow down the result. So I can also add another condition, sales amount greater than or equals to, and then give, say for example, 5,000 would further reduce the number of rows. So this has the same effect as combining all of them using the AND operators. There is also a simple mechanism to work with conditions. This can be done with the help of a $where operator, which takes a string representing a condition. However, these conditions would operate on the properties using the JavaScript notation. Let's take an example. db.sales.find $where and a string, and here the properties must be accessed with the help of this keyword, where this represents the current object or current document being processed. So what MongoDB does is MongoDB going to take every document in the sales collection one by one and checks this condition, is it true for the current document? And if that is true for the current document, that is prepared for the output. If not, it's ignored. So if I give here this dot quarter equals to 1, notice the double equals because this is JavaScript, and then I can say R, and then I can say this dot quarter equals to 3. This has the exact same condition as in the $R operator where we said quarter equals to 1 or quarter equals to 3. So let's give it a try and see how many documents match this condition. So I'm going to go type here Mongo ex09.js, and it's coming back with 138. So if I go and change this to say for example 4, now I should see a different result. We can also say something like this dot sales underscore amount greater than or equals to 5,000 and this dot sales underscore amount less than or equals to 6,000. So this is a very simple mechanism to execute a query. Using grouping techniques, we can get summarized data from a collection. This can be done in a couple of different ways. Let's have a look at the aggregate function first. For this demo, I'll be using a collection called employees. Here is what it looks like. Let's say we want to find the total number of employees in a particular department. So this is what we can do. db.employees.aggregate. The first parameter to this is the grouping option. We have an operator called group, and then we have to specify what is the ID to be used. The ID here is a property on which we want to group. Since we want to find out the total number of employees working in a department, so this has to be a department. And in order to specify that this is not a value but this is one of the property, we prefix this with $. So hence we have to use $department. This is followed by the new column or property that we want to get, so which may be an employee count, and we have to specify how this count is calculated. Now unfortunately there is no operator called count, so what we can do is we can repeatedly add 1 using the sum operator for every employee in a particular department, and this gives us the count of the employees in this particular department. So let's save this and see if we can execute the same. As you can see, we have a nice summary of department and the number of employees working in that department. Let's take another example. This time I want to find the average salary of every employee in a particular department. To do so, I can just comment this and let's write one more query. db.employees.aggregate. As in the previous case, the ID property would be the department, hence $department, average salary for that particular department, and we can use the operator called $avg on the field salary. Once again, like $department, we are using $salary because if you do not give $salary but just salary, it will assume salary is a text and not a property. Save it and run the same command, and we get the average salary in each department. We can also use the match operator to reduce this output from displaying all the average salaries to only where average salary is more than a particular limit or less than a particular limit. For example, let's say we want to display those departments where an employee earns an average of more than $4,000. So I can use another operation here and I'll say $match, and what is the match criteria? In our case, we wanted to say the average salary to be greater than or equals to 4,000. Save it Run the same command, and this time we'll see a smaller subset where every average salary printed is more than $4,000. And if you want to order the output in a particular ascending or descending order, we can use that as the third parameter to the aggregate function. So we'll use a $sort, and then we specify the property on which we want to sort. In this case, AVG salary. And if you want ascending, you can give it as 1. If you want descending, you can give it as -1. Let's save it and execute the same. And here is the output. Another great tool for grouping MongoDB documents is a function called MapReduce. At first, this may look a little complicated, but this has got more power than the regular aggregate function. So let's go check this out. The MapReduce function takes a couple of parameters. First, let's say db.employees.MapReduce. The first argument is a function typically named as map. The second parameter is a function generally known as reduce. The third one is a bunch of options that we can supply. Now at this time, all these are considered as variables, and I don't have these variables. Let's create one by one. Function map, function reduce, and var options, which is an empty object at this time. The map function will be executed for every document in the employees collection, and we have access to that in the form of this. The map function generally calls another function called emit, which sends a key to be used, for example this department, and then a value that we want to summarize, for example this salary. The outcome of the map function is a key value based collection where we will have unique department names as keys, and for every department we will have an array of salaries. Now that collection is supplied to the reduce function with a key and values. So if this map function was called for every document, and we have, let's say for example, n number of unique departments, the reduce function will be called exactly n number of times where a key, which is the department, and an array of all the salaries is supplied. So what we can do here is to return an object which is a summary of this particular values. For example, I can simply return array.sum of values, which means we are summing up all the salaries for a given department and returning that. So the outcome of this reduce function is that MongoDB takes the key and the summarized salary and then we'll add it to its bucket. At the end of this, the entire bucket, which is a key and the sum of salaries, will be given to us. This options tells us how to handle the response data, and at this time we can simply say out is inline. Save it, and then we can just access this as Mongo ex13.js, and we have a summary report. So if you carefully observe, each department is displayed one time, and this happens to be the sum of all the salaries. In the beginning, I mentioned that MapReduce offers more power than the typical aggregate function. That's because we can control whether or not a particular piece of data is emitted based on certain condition. For example, if I don't want to include the salaries less than or equals to 4,000, I can do so by simply adding a condition. If this salary is less than or equals to 4,000, return, which means out of n number of documents in the employees collection, certain of them are ignored based on this condition. So now if I save and access the result once more, you'll see that the numbers are different and smaller compared to the previous one. Also, we can add less number of departments to include. For example, let's say I don't want to include sales, services, support, and training. I can add one more condition. Save it, execute the command once more, and you will see that in the output we do not include sales, support, services and training departments. By default, MongoDB scans every document in a collection to select those which match the query condition. If you have a query that uses a particular field and the query is used by the clients quite often, then we can create an index for the field so that the performance of the query can be increased. MongoDB offers different kinds of indexes, and the most common one is the single field index. Before we create this index, let's have a look at this command. We are searching a contact using a phone number. We can ask MongoDB as how did it arrive at this particular result by calling the explain function on the find. The result shows which one is a winning plan, and the winning plan says that it is call scan. Basically it says the phone number was searched by matching this phone number for every document until it found or it is not found. This is quite inefficient if the query is repeatedly being used. To avoid this, we can now use an index. First, let's see what are the indexes that are currently available by giving db.contacts.getIndexes. And it says that there is only one single index on the field _id. _id property is indexed by default for all collections. For example, db.employees.getIndexes also shows me that there is one index on the _id. And we can go and check for all the collections and the story is same. Now let's create a new index for the phone property of contacts. To do so, db.contacts.createIndex, and then we have to say phone to be indexed. Now it gives me a message saying that number of indexes before was 1 and number of indexes after is 2. We can verify the same thing by issuing the command again to get the indexes, and we do see that there are 2 of them. Now we can also ask MongoDB to explain the query if we execute it now. And now you can see that out of many plans it came across with, it now uses an IX scan, which is nothing but index scan. If you want to drop the index, db.contacts.dropIndex, and then specify which is the property on which you want to drop the index. So I have here phone as the property, and then I can just say drop indexes. Now it says number of indexes was 2, which means now it should be only 1. We can also check it out by getting the indexes listed, which says that there is only 1. And also we can check the explain functions result, which is now going back to the call scan. Let's have a look at updating documents. And for updating the documents, let's take a different collection. And I have another JSON array document called products.json. Let's import the same thing into our MongoDB database. To do so, let's execute the Mongo import with JSON array. And the database that we want to use is the test.db, and the collection that we want to use is the same name as the product. So I can just type here products.json. Now, since we didn't mention the collection name, it's going to take the base name of this file, which happens to be products. So let's execute, and it says imported 85 documents. Now, one thing you can observe this time is that if I run the command once more, it's going to result into errors. And that's because if you observe, we already have _id property for every document. If you try to insert it again with the same _id, we get the error. So now that we have got all the documents inserted, let's have a look at what exactly we have. I'll say use test.db, show collections, and this time I want to say db.products.find.pretty. Let's say we want to modify a data for one of these products. For example, let's say the name of this particular product for 19, instead of brinjal, I want to change this to eggplant. And to do that, we would be using the update command. So we'll say db.products.update. So the update takes few parameters. The first parameter of this update function is the query. So the query happens to be underscore ID is 19. The second is the document that you want to give. Now, if I just say that I want to change the name of this from brinjal to eggplant and press enter, now it says that number of documents matched is 1, number of upserted documents is 0, and number of modified documents is 1. And if I go and have a look at whether it has updated or not, db.products.find.pretty, and you should see that the product number 19 is changed, but not as we expected. We wanted the name to be changed, but it has replaced the entire document. So this was a bad idea. So in order to change only one or two properties of an entire document, we should be using an operator called set. For example, let's do the same thing for this one, except that instead of the brand Fresho, I want to change this to brand Malnad. And to do so, this time I'm going to use db.products.update. I'll say the same query, this time underscore ID is 20. And then the document that we want to update happens to be $set. And then we say what are the properties that we want to set. So I'll say here brand happens to be Malnad. And if I want, I can also add another property which is currently not existing. For example, I may say that details, and I can say here something like this, which I don't have any details at this time. So I close the bracket for the set operator and close the bracket for the modifying document. And that's the end of the update function, so I can execute the same thing. Again, the same result. It says number of documents matched is 1, number of upserted document is 0, and modified document is 1. Unlike the previous one, now if I execute the find method to retrieve all the values, you will see that the document 20 is intact, except the brand is changed. A new property called details is added. Suppose I want to find a product whose ID is 100 and then I want to update few properties of that product. So we would say db.products.update and the query is underscore ID is 100. And then the updating document happens to be a new one, probably. I can say name equals to test product. And then I will say unit price happens to be, let's say 100.0. And a description of the same thing happens to be test description. For now, I think these properties should be good enough. Let's save this and then run the same thing. To run that, I'll say Mongo less than ex10.js, press enter, and it comes back with a result. The result says number of matched documents is 0, upserted 0, modified 0. The reason is very simple. We don't have the document with an ID of 100. So let's go check it out. I go to the Mongo test DB. I'll say db.products.find underscore ID is 100. And you can see that it came back with nothing. We can also ask MongoDB to insert a new document in case if the update failed. Now this concept is called upserting. So we come back to this particular code and then we specify here a third parameter where we say upsert is true. We say that search for this document. If it is found, you need to change this as the new document. If it's not found, you need to add that, update or insert. So one more thing is that if the product already existed with multiple fields, all the fields will be lost and only these fields will be the new fields. So in order to avoid that, I can say $set and then we can specify all these properties. So let's execute the script and check the result. And this time it says number of matched documents is 0, number of upserted document is 1, modified is 0, the ID generated happens to be 100. and that's because we supplied that. Let's go and verify the same thing. Type Mongo test DB, and then I'll say db.products.find1 with an ID of 100, and there we see the result. Let's say we want to increment the price of all the products of Fresho brand. So first let's find out what are those products. So we get into the Mongo shell test database, and then I'll say db.products.find, and I'll give the condition as brand is Fresho, and we can also say pretty so that we can see the results properly. So there are many of them. Let's see the last few of them where the product price happens to be 29, 35 and 39. And we want to check if that increases the product's price for all of these. So let's write the query for the same thing. So we say db.products.update, and the criteria happens to be brand equals to Fresho. And then to increment the price, we can say $inc for increment. We say unit price and the amount being incremented. Let's say we want to increment this by 5 rupees. So it says here that find all the products with this brand Fresho and then increment the unit price by 5. So if it is 30, it should become 35, 35 becomes 40 and so on. So let's see if this works. Save this and execute this. When I execute, it says number of documents matched 1, upserted is 0, modified is 1. But we saw there are many documents matching that condition, but there was only one update took place. Now this is because by default MongoDB updates the very first document that it finds. Now since in this case it was quite arbitrary, we don't get the desired result. You can go and verify that also. Alternately, we go here and then specify a third option where we earlier gave upsert. This time we don't want to really upsert, but we can say here multi as true. Now by default, multi has been set as false. So we save this, we run the same thing again, and you can see this time it says matched documents are 56, modified documents are 56. So we can also go to the Mongo shell and check db.products.find, and we say brand Fresho. We'll also say pretty. So if you remember the last few outputs, we had 35 for this, we now have 40, we had 39 and it is 44, and we had 29, that's changed to 34. So this way we can update multiple documents as well.